Let's describe the contribution of ATOS to CloudButton project so far. We lead two technical tasks, testbed and validation, and instrumentation and quality of servers. We have contribution in other tasks in work package 2, work package 3, and work package 6. The table shows the deliverables in which we have participated and the tasks described on each of them. We have also contributed to the paper Server Mix Trade-offs and Challenges of Serverless Data Analytics in 2019. Let's describe our progress in the task 2.3, testbed and validation. We will talk about what is the contract that we had with ITER for the definition of our nodes, what is the software that we have installed so far in the nodes, and what is the future work that we expect to do in this task. In ITER placement, we have 3 bare metal nodes with the features described in the table. We will refer to the nodes as node 2, node 3, and node 4 from now on. As you can see, they have slightly different storage and memory features. Also, we have one private network that connects the 3 nodes and that is accessible from the VPN provided by ITER, and also one C public network. The throughput of the network is 2 gigs. For nodes 2 and 3, the different disks that made up the total capacity are set on a RAID 1. Instead, for node 4, there is no RAID, and we obtain 2 volumes in which we can install our object storage. The main software that we have installed in the nodes is the Kubernetes cluster. We have installed Kubernetes version 1.18, and node 2 is the master of the cluster. Also, we have installed Knative Serving and Eventing version 0.14 and the Knative Observability plugin. IBM Pipedrive is also installed. Pipedrive functions are the basis of CloudButton's serverless data analytics platform. The CloudButton SLA, that is one other contribution of ATOS, is also being developed and tested in node 3 of the testbed. This is Knative running on our Kubernetes cluster. And this is the CloudButton SLA running on node 3. We have also installed a Ceph cluster. All 3 nodes are monitor services, and the object storage services are running on node 4, where we have the 2 disks that are used for the storage. We are in the process of installing Rados Gateway on an Ubuntu virtual machine that will run on node 4 to provide the S3 API compatibility that is necessary to access the object storage. Finally, a mini object storage is being installed on the Kubernetes cluster to make use of the storage in nodes 2 and 3. This storage is also accessible using the S3 API. Finally, Metaspace Annotation Pipeline Jupyter notebooks are running on the testbed from our Metacolonic use case. 2 configurations are possible for the computer backends, either IBM Cloud Functions or the Knative running on the testbed. The computer storage is the IBM host. Once the configuration file is set, you can run the experiment from the Jupyter Lab installed on node 2, as displayed in the image. The expected future work in our testbed is to define a backup scheduling for the data between the 2 object storage, integration tests for the use cases to take place on the testbed, and the CloudButton SLA to define an appropriate SLA for the performance of each of the applications. Let's describe task 3.3, instrumentation and quality of service. We will describe the decision taken in the process of defining CloudButton SLA. ATOS SLA Manager can identify the breach of an SLA. It provides a REST API in which can be defined the agreements that made up the SLA. Then the evaluator makes sure that all the agreements are being fulfilled from the data obtained by the adapter. If this is not the case, a violation will be notified. An observer can use this information. The SLA is made up of one or several agreements between a client and a provider that is on a state, and it has a creation and expiration date. The agreement is made up by different warranties. The warranties I described by the metrics that I provided by the adapter. In order to adapt our SLA Manager to CloudButton, we have to answer some questions. Do we have monitoring data available in our system? From the data available, can we describe the quality of service of CloudButton ecosystem? Can we define an SLA agreement to beat the quality of service out of these metrics? How can we make the quality of service information available to CloudButton components? This is part of the high-level infrastructure of CloudButton. The CloudButton SLA is part of the CloudButton core. The CloudButton core is linked with the backend path where Knative is running. We will install the Knative observability plugin. It supervises the health of the pods running on Knative. The Knative observability plugin stores data retrieved in Prometheus, and it is analyzed in Grafana. It installs several dashboards in Grafana to supervise Knative. It also made use of other metrics provided by Kubernetes. So this will answer our first question. What monitoring data do we have available? We have available the monitoring data provided by the Knative observability plugins and the Kubernetes metrics. This is the output obtained on the Grafana dashboard from the execution of a process in a Knative serving. This information is provided by querying the Prometheus monitoring. So this will answer our second question. What are the parameters metrics that describe the quality of service of CloudButton ecosystem? Those are the metrics that are saved into the Prometheus monitoring. We'll need an adapter to read this information and obtain these metrics on the CloudButton SLA. This is a query to the Prometheus monitoring using its REST API. As we can see, we have a result that can have different types like metrics, vector, scalar, string, and then it follows the value of the metrics. The metric is made by the value itself and the timestamp in which it is taken. In this example, the metrics are grouped. So, from the point of view of defining agreements to make up an SLA, we can use the metrics that we obtain from Prometheus as variables that define the warranties when setting the constraint on these metrics. Then on CloudButton SLA, we will get a violation every time the metric is not fulfilling the constraint defined on the agreement. So this answers our third question. Can we define an SLA agreement to meet quality of service out of these parameters? Yes, if we select the appropriate metrics that we will take from the ones that are used to define the Grafana dashboards. CloudButton SLA has also implemented a notifier on RabbitMQ. In this screen, we can see what is the payload of the message that has been posted into the CloudButton queue after a violation. So this answers our fourth question. How can we make the quality of service information available to CloudButton components? So the other components can consume this information for our Rabbit queue. For future actions in the CloudButton SLA, we plan to fully define an SLA to supervise CloudButton core components and running processes. We consider adding dynamic information to the SLA definition, like number of pods, namespaces, etc. The existing baseline of metrics in Prometheus can be completed with specific exporters if necessary. This is a demo on the work done on a CloudButton SLA so far. The SLA is made up by different agreements. An agreement is signed between a provider and a client, and it has a creation and expiration date, and it has to be on a started state. An agreement is made up by different warranties. All the warranties has to be fulfilled. If any of the warranties will be break, then a violation will be raised by the system, and the other systems can be informed. Warranties are defined in base of metrics. We are developing our CloudButton SLA from the testbed of the project. The testbed of the project is a Kubernetes cluster. We can see that in our cluster, Knative is being installed. Knative eventing, serving, and also the monitoring. We will use Knative monitoring Prometheus to collect the metrics that will make up the agreements of the SLA. These Prometheus metrics are being grouped in different Grafana boards. From here, we access 154.48.185.2. That is one of the nodes of our cluster. And this is a Prometheus access to the different metrics collected by the Knative monitoring. Also, with the Knative monitoring, different dashboards from Knative are installed in order to supervise Knative processes. As you can see, now we don't have any metrics produced as we don't have any process running. To run this process, we are going to use the Metaspace use case. We have a Metaspace Pyron annotation pipeline installed on our node 2 of the testbed. We will run the Jupyter notebook to have access to the different experiments and run them. First, let's start our SLA. The adapter that is used is the Prometheus, as we said, and all the violations will be notified on a rabbit queue. So far, there is no any agreement that is in place in the SLA. So first step is to set up the agreement. For this, we will use our API REST. And now we can see how the agreement starts being evaluated. The agreement is just identifying when any of the reconciler metrics are being greater than 10. So far, they have no metrics, so all the values are 0 and no violation is being raised. Let's start running our experiment. For this example, we are using the compute backend Knative, the Knative from our cluster, and the IBM host storage. We will see immediately how the Grafana is going to show some metrics. The agreement is based on this reconciler metric. So let's have a close look to this one. We can see that here some of the values have raised a value bigger than 10. So if we go back to the SLA, we can see that some violations have been published on the queue named CloudButton. Let's have a look at this queue. And yes, we can see that the violation of the guarantee reconciler less than 10 has been produced in the date of today. We can see how it continues raising new violations until the experiment will end. On task SID.1 communication strategy and plan, the progress is the following. Inputs to delivery 6.1 regarding the activities performed by ATOS in the first 6 months of the project. A new proposal for restructuring the deliverable 6.1 communication plan. On task SID.2 dissemination committee involvement, contribution to self-mix paper, the participation in the European Big Data Value Forum, where ATOS had a booth, a short piece of news in the ARI newsletter, the press release in Spanish distributed by Planetec, and everything reported in the deliverable 6.2. Thanks for viewing this video.